it if you have if you work with the scikit-learn, they provided some basic data transformation or processing data, or even you can use it for the test train test splitting data, normalization, and so on. And also you can use the matplotlib. It's for the from the name, matplotlib means that we play on the matrix plot library, so it's related to the visualization. And then we go through after you already finish with your preprocessing. Next, we try to modeling and analysis. On this part, we build model, we build algorithm, we build a method. Means that if we are related to this, to data science, then we should use the machine learning model or deep learning model and so on. So in Python, we have some packages that we can use. You can use NumPy. It's more related to the factor or array, and then SciPy. It's kind of like statistical model. Also, the stats models too. And we have SymPy if you are working on symbolic, like the integral as I shared you last time. And we have the sklearn. It's like it's scikit-learn model. In sklearn, mostly we have well-defined or well-prepared machine learning models. The conventional one. So why I mentioned that on that pipeline, on their pipeline, they already put like some optimizations algorithm to help find the best tuning parameters. So if you are familiar with machine learning, actually, why we always train the model, because we want to find uh, a good fit one, not the overfit and not the underfit case. But we want to find a good fit, and mostly we we do trial and error. But with this package from scikit-learn, sklearn, they already provided with some uh, optimizations algorithms so that the result, uh, I do believe that the result already optimized. So if I'm not wrong, I don't know, for now, I've been like so long to not use sklearn because it's more conventional one. They put great search method to help you find optimal parameters on the conventional machine learning model. So what is the conventional machine learning model? You can try to find like linear regressions, logistic regressions. The most famous one back then, before deep neural network become famous, you can try to search support vector machine. And we don't know, maybe someone still trying to work on the SVM, but more deeper. So we have deep SVM, we don't know. And we also have the multi-layer perceptron, even though the MLP or the multi-layer perceptron, uh, a base model for deep neural network, which is they only have like 2 layers only, but it's still considered as the conventional one because it's not deeper and it's really uh, still black box model, but still we still can follow what happened inside the model. Follow means that we still can calculate manually follow the idea of the MLP, but we may not have the exact value every time we do the iterations because we have random initialized parameters. So that's the difference when that's why we don't have the same or exact value or result or outcome from MLP. So I still say it as the black box model. And last time we have TensorFlow. So this package help you to work with the deep neural network or deep learning. So until now, deep learning still highly related with deep neural network. But if I mention certain research field, some people still doing like data mining stuff, like the frequent item set or the sequence pattern mining, where we still don't know, maybe some of those researchers trying to build uh, like deep learning one, within deep learning concept. Because those methods that I just mentioned, they are more related to the explainable AI because they still consider as the white box model. We can't really know what happened inside the model, and we can see the output, not only the accuracy, but also the rules or the classifier. Let's say if we talk on the classification problem. So we know the F then rules from the like sequence pattern mining and frequent item set. But currently, they didn't do the deeper one. Within deep learning concept. So we still don't know. Why I always mention that, because deep neural network back then it's something like that. People around the world like so much with superfactor machine, because back then neural networks are really heavy. For the computation, it can be like 1 week, it can be like 1 month if your data is big, and the result are not like now. Today we can have like 90%. It's always like uh in between superfactor machine and the uh neural network. Why so? Because the heavy computation. So even though we put more and more data, by means that we have more time computations to deal with. But then we have GPU, and until now we have TPU. Then everything like looks possible. But now people again wants to back to the on the fly model, means that the efficient one, but still bring the deep learning model because currently we have a problem to build like GPU and TPU, not for like the software one, no, but for the raw material for the hardware on GPU and GPU. Back then, like 20, if I'm not wrong, 2018 or 19 or 17, I forgot, in between those years when I was PhD. So in Taiwan, I was study in Taiwan back then. So I was study on Taiwan back then. So on those year, I still remember that some semiconductor company cannot uh, construct or build the GPU or TPU because they don't have the gold, if I'm not wrong, or the raw material for GPU and TPU. So since then, some people try to like wants to make it back, how to build deep learning in efficient way, but still it's related to the hardware too. So after you successfully build the model and do the analysis for your outcomes, And then we go the evaluate and present. Okay. So again, I put present because that's the big difference when you work on data science, because you need to communicate your result, you need to communicate your data, you need to communicate your work to others, to convince others to validate your result, your work. So you need to present it to them. So here you can use Jupyter Notebook by using the Matplotlib, and you have the Poker and Flash, and actually there are many more about tool data science actually. Outside this, you also can use the Power BI, I mean outside Python, and you can also use Tableau and so on. So lecture goals for today are a real research project that uses for data science. I mean, I just give you some example you can try by yourself and then learn more about each step by showing case code and example. I mean, I just like screenshot the code. So here we try to do the restaurant ratings across sites, not only from one site. In this example, we will play on three sites, three social media sites. So here customer rely on online review and ratings to decide where to eat. But the same restaurant seems to get different ratings and reviews across sites. So is it true, or what might be the reason? So what I mean, let's say we bring like Google and Facebook with the same restaurant, but we will get different rating reviews. Why is that? Because it depends on the customer on Facebook and customer on Google. Maybe we have the same customer there, but I mean, we have the same account, same people, same person, I mean. But maybe that person really like use the Google, and some other person, another person like uh, really like to use Facebook. So that's why it can be happen. So based on this hypothesis and based on this, let's say imaginations from you or from us, then we need to try to ask why it could be happening. So this is like when we search on the Kali Club on Yelp, Google Facebook. So from Yelp, we have 3.5 out of 5. And then we have Google, it's 4.2. And from Facebook, it's 4.5. So why on Yelp, the rating was bad compared to Google and Facebook? So we try to assume, or we try to make an assumption. Again, data science is always keep asking or keep making questions. So why it happens, as I mentioned before, even though on Yelp, Google, Facebook, uh, a person have these three accounts, but maybe he really like to use Facebook, or maybe he really likes to use Yelp. Another assumption, it's like maybe Google and Facebook are more public one compared than Yelp. I mean, for Yelp, maybe they have like more private customer or more elegant, let's say. I don't know how to say, how to interpret it. But I can, I mean, what I assume is that on Yelp, uh, social media Yelp, we can have more highest standard on Yelp than Google or Facebook. We don't know. It's just an assumption. So we need to prove our assumption actually. then we try to manually examine several restaurants to show from those three social medias, we have a different rating. So for most of them, the rating is highest on Yelp and lowest on Facebook. It can be vice versa. Let's say we have like extreme food, but for certain people on the higher standard, let's say for the richest one, they do really like it. So that is why they put like high rating on Yelp. But for like most people, it's kind of like really extreme. So they don't like it. So they put like a bad review on Facebook or Google. So if we talk about the Epstein file, those richest family or people have tends to have like crazy behavior, so crazy taste. So like yeah, we don't know, right? So maybe they like to eat like flesh, human flesh. We don't know. They really like it, so they put like high rating. So let's say on that circle, on their circle. But for most of us, we don't like it. It's cannibal, right? So we don't give them like a very good rating. So let's say something like that. We don't know. So how can we verify this hypothesis? We need to get more data in a systematic manner. So systematic manner is somehow we can play with statistical, we do the data analytics, but we also need to bring the intuitions so that people or your customer can understand. So let's say, yeah, you are very good on data science or AI or machine learning, but if you communicate with your customer in that way, too technical, then maybe they don't understand and they don't feel like interested at all. So you need to also bring the intuition part. So let's say like fifth grade can understand. So it's also somehow it's difficult. So when I follow the conference in Spain last week, last 2 weeks actually, I really find that some PhD there are PhD student and they are from industry. So I found a big difference when like PhD student they really talk technically. So somehow, yeah, some people on that field really interested because they really know the technical part. But for the industry, they really like hard to follow, let's say. So when I try to observe, they totally have different way. So industry, they bring two ways. So technical one, which also I mean along with the intuition so people can really understand and can really see on real applications and it's really interesting and I also find a professor uh, he tried to bring mix in between technical and intuition so there are a bunch of like questions coming uh, because people will try to relate to the application and also how to solve it and yeah and so on. So that's what I want to say in the systematic manner here. So how should we interpret the discrepancy in ratings? What could be the reason? So yeah, as I mentioned, perform data analysis to get more insight. Step one, get the data. So what data and how much data do we need? Okay. So let's say we need ratings and reviews on Yelp, Google, and Facebook for at least 1,000 restaurants. important, make sure that the data set is aligned. So we should use the same set of restaurant for all review sites. So how to get these ratings and reviews? So here, Yelp released data set of reviews and ratings and their data challenge. So you can find here on the www.yelp.com slash dataset and slash challenge. We can sample some restaurant from Yelp as a starting point, and then find the corresponding review pages on Google and Facebook. And both sides provide APIs for this. APIs mean that we need to pay. This is like just telling my story back then when I was PhD. So when I tried to do some trajectories, I need to pay. I need to make a lot of Gmail accounts to get free API keys from Google Maps. Back then, I still can use it, but now they do. I don't know. In Indonesia, they do a restriction, but I think it's the same for others. For Gmail account, you need to put your phone numbers so that we cannot like make a bunch of Gmail accounts, unfortunately. But back then when I was PhD, I still can do it like that, do cheating, so I don't need to pay uh a lot of money because it's for me back then when I was student, it's like really expensive. I can like get 100 trajectory by paying $20 back then. So I don't want to do that. So instead of it, I make a bunch of like Gmail account. But here we can make it a little bit cheating again. I don't know whether still can use or not for current conditions, but let's see when you try it by yourself. So from here, not only like this, so more practical one. Yeah, it's also can be say a practical. What I mean, if we talk about manufacturing industry, you will find really difficult one to get the data. So, manufacturing or medical health, but medical health you can still find it, but for manufacturing it's really hard. So when I was in conference, as I told you, there is some industry who also present their research or their findings. So he also mentioned about you will not be able to find the manufacturer data because it's kind of like really strict and private one. So they cannot share the data. It's really like a company private things. So if he say that if you want to do some smart manufacturing, then you need to like really have a good connection with the company, or you can like give and take with the company. And it's true, we have a public data for manufacturing, but it's really, really not like the actual one. So why I say that, guys, because I already have an experience with the manufacturing for the cement factory, and also for now because I have like a doctoral student from Aramco Oil and Gas, so I can really see the real data set from the manufacturing, and it's way totally different from what we have on the public data set. But at least um, this is what I want to emphasize to you. When I trying to do the beauty contest, what is the beauty contest? Which mean that we do like competition with others, let's say company and also others university to get project. We present to the yeah, the one who has money here or the one who has the project and share their funding. So when the problem is on the manufacturing and they haven't shared their data yet, So to convince them, somehow I need to search public data set that related to the project that we may have or we may get, or the offered project that we will try to get. So I try to find the public data set and try to do the data analysis and so on. Even though it's not like really related, but still like do in the same domain, maybe they still can have some interesting. So here the search places on Google, yeah, to get your API. You can try later on. But how to get reviews from Google and Facebook? Both sites have some data APIs, but no API for accessing the content or rating of reviews. We have no choice but to crawl the web page. Sometimes this could be the most challenging and time consuming part, but when you already make it available, so then you really can help most people on the on academic field. So try your best to but actually try your best to avoid crawling data. So here kind of like the crawling web page. So you need to search and you need to like collecting whatever information that you need, and then typical workflow, construct a URL that contains your data. This could be hard. You may need to read the source code of the web page to figure out the source of data. And finally, we have the following magical code for constructing the URL of review data on Google. So somehow, yeah, it's kind of the tricky one that we should do. Like when I was in my PhD, I do need to make like a bunch of Gmail account and then make this kind of the URL and put the API key, and we can play. We can retrieve the data set that we want. And then we use the request library to get the HTML. So like this one, you can try by yourself later on. And then important, use the HTTP proxies to avoid being blocked by the site. And you will almost certainly be blocked without using proxies. Ideally, you should create a pool of the available. So again, it's not easy to get like a data actually, guys. Even though it's public, somehow we need to do extra step. And then use the beautiful soap and or regular expression and save the structured data to a CSV file. Yeah, mostly we play on the CSV file, but if your data is very big, then you can try to convert it to H5 uh, file extension or others. There are a bunch of like the, if I'm not wrong, we also have the YAML too. Yeah, a bunch of conversion file extension actually already provided. But don't worry, you can try to find out on the Reddit or on the Stack Overflow. People already try to make a discussion. We always keep trying to help each others to there so that we have um, a great job in the machine learning. So again, this could take several days or months to finish because you need to deal with the proxies and so on. Yeah, they will put like limitation still. For this project, it took 2 weeks to crawl all reviews for about 5,000 restaurants on Yelp, Google, and Facebook. And step two, the pre-processing. Raw data needs to be pre-processed. For this project, we mostly use pandas for pre-processing. And if you still remember on the Yelp, we have the customer reviews. They put their feedbacks, so it's related to the text. So we can use an LTK for some easy text processing. Important, always do data spot checks. So what is the format of your data? What fields or features are in your data set? And do you see any obvious problem with your data? I already give you like a certain example on the first meeting. Any obvious problem? I don't know, maybe like we still can find missing value or even though on the missing value, some data set they didn't put like in beautiful way. I mean, sometimes it's not like 99999 to make it its amazing value, but they put like suddenly we have numerical field or features, but they describe it the missing value with text. So none, let's say, so it will make problem in your code, but it's just a simple problem. You may do like preprocessing. See, look at your data, find potential problems in data, spot check plus general experience with a specific type of data. Do we have restaurant that have a lot of reviews on one side, but very few or even zero on another side? Yeah, it depends on the customer, as I mentioned, the customer preference on social media. If we do, shall we filter them out? Of course, we should do it. But does this filtering introduce bias? Depend on your analysis. If you put too much your viewpoints, then it could be biased because it will contain your preference. So that is why we should play with or work with statistical or mathematics, if you want to say that, guys. So since we are dealing with textual data, there are several things to pay attention to because computer just only understand numerical things. Does every review has textual content? We should think about this. So I don't know for others. I mean for Matthew and so I mean international student. Uh, I found in a final project from students here, they do some news for stock price or for the carbon price predictions. So they try to elaborate with news. But the thing is that news, or let's say from social media X, so it's not always I mean people try to comment on stock price or even for carbon price prediction. So this is the problem. So we have the carbon price each day, but the news is not always talk about the carbon price. So how could we elaborate balance here? So we cannot just augment the data by copy and paste because we should really understand why we do this thing. We should to have to know the relations between some people comments that in fact are affected the carbon price prediction or stock price. But if we remove all the data, it's also a problem. Why? Because as I mentioned, if the data is insufficient, then we don't need to use machine learning model. We just use statistical or mathematical model. So we need to make sure the data set is also sufficient so that we can work with the machine learning model. Okay. So it's also a good question. Does every review has a textual content? And then are the review always written in English? We need to make sure. So we need to transform it. Even though sometimes nowadays with with your generations, they put like emoticon, so it's not text any longer. But some researcher already tried to deal with it. Even though we have emoticon, we can still put it as the review. Back then we deleted, but now they try to work with it. Are there special characters in reviews such emojis? This one, this causes decoding problems. But some researchers are already try to deal with it. But the easiest one, we just delete it. But if you really want to know the emotions of the customer, your customer, you need to uh, or the emojis here. Here, loaded the Google dataset. You can try here. After you already get the data set, then you just trying to load the data and put on the, so here actually is the data frame, but you need to import first if you really get familiar with the machine learning. So import data frame as PD, and then you can use this one. And this is the data from Google Review. We see review without textual content. And then what portion of reviews do not have text? So we try to filter out the Google review without text. So by having like here dot not know, and only 70% of Google review have textual content. And then we notice that Yelp review seems to be longer. What is the average review length in words and sentence? On Yelp, Google, and Facebook actually. Then we can use the NLTK here by taking the tokenization. So where we have a word or term here. So I have been like work on the NLP, but yeah, no, but and we found that word, sentence, paragraph, it's really important to see. Even though we have a bunch of sentences, but if the words are same, so some people tend to write redundant word, then the data could be not informative enough to see or to be analyzed. Then we try to check the distribution of the number of sentences. So on the Python, we have dot describe here, and you will suddenly get count for the text length, the mean, the standard deviation, the minimum, the first quartile, and then we have median or the second quartile and the third quartile, and we have maximum. So by using the dot describe, you will get this information. But for now, we have more beautiful form for this one and more complete information for the distribution for now. It's back then just like that. And then we try to summarize the basic statistic of our dataset from the Yelp, Google, and Facebook. Now, as you can see, that the number reviews on Yelp is longer than Google and Facebook. And then the average of reviews, it's also a lot of reviews from Yelp than Google and Facebook. also for the average length on sentence and words. And the total reviews from Facebook are longer than Google, but with text, uh, Google has like the higher one, but for the average length or on sentence and word, um, Facebook still has the uh, longer one. So it's quite interesting. It's quite I mean contrast one. But what we can see from Yelp, it's the highest one. And if you still remember from the curry restaurant, they have a bad reviews. Maybe why it's longer reviews because the customer put effort to give the feedback. We don't know, like in angry statement. Not only I don't like it, but blah 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 and so on. So then reaching these distributions, recall that our goal is to see if the distribution of restaurant rating is different across site. We should plot the distribution. So visualization, right? So when we do the analysis, it's better to play with visualization, guys, to see how is your data behavior, how is your data looks like actually. So we should plot the distribution of ratings at per review level and per restaurant level and see the difference. And this is like how we try to extract the rating distributions. So we try to count the review score from Yelp here. And then, yeah, this one actually how we count it. And we have another places here, not no review score count because maybe here we have a problem on the Google. Some people may not give provide the review ratings. And we have the FB review. So for Facebook, we don't have like this. Means that all the customer already provided the rating reviews. And then we try to merge all. We try to combine the review from Google, Facebook, and Yelp. And this one, yeah, we try to merge it here. And then we try to rename it and we try to sort it. So this one, what we have on our data frame, starting from here actually, because we already, oh no, because we do the sort values. So that's why it's like random, but we try to sort based on this star rating here. And then we try to do the plot. It's the common one when we play with Matplotlib. So you need to import first, import Matplotlib as PLT so that you can get this one, the plt.zp, plt.xlabel, yeah, for the x-axis. Yeah, yeah, maybe because of the student, I don't know. But as far as I remember, for the all professor who present on the conference, or if yeah, if we pray already there, we are uh always or not always, we must give the information on the x axis and the y axis. For title, somehow we don't need to because it depends on the situation for the title of the figure. But for the no, but for the title itself, we can put it on the title of the slide of your PPT. Because if you really want to share your one figure, so you don't need to have title on your figure, just put it on your slide. So we try to tell a story from that figure. But some students still like, especially some student in in Department of Mathematics, I still found that they are that they forgot to put the information of the x-axis and the y-axis, where we don't know what is the x and we don't know why it is the y-axis, but they keep like present, and that's like disaster. We don't follow your presentation in that case. So you must give the x and y axis labels. This one just to make change the font size on that X label and Y label. And if you want to save it, then just save for here. So this one are the ratings distributions per review for what actually we have. This one is the rating, sorry, the distribution, the probability, and this one are the review star rating. So for here, I don't give a title because I just want to share this figure, so that is why I put the title on my slide here. So ratings distribution per review. So this is what we get from Yelp, Google, and FB, and of course we need to make sure the legend. So what is the blue, what is the green, and what is the red? Again, I still found some student. So when they defense their final project, uh, previous semester. So yeah, this maybe it's not like important for you, but it's really important for your audience to follow your presentation, to follow your lecture, let's say, or teaching. So from here we can see that Facebook, let's say we do some imaginations or we have assumption from this to give intuitions to our customer or our audience. So as you can see here that Facebook has a very nice customer because they always put 5 reviews, 5-star reviews. Meanwhile, Yelp, it's kind of like strict customer one, because uh, we can see that almost compared to Google and Facebook, Yelp, for 5-star reviews or ratings, the lowest one, but number one, the bad one, he has the highest one, as you can see here. So from this figure, I really want you, if for the data science course, you not only say that, okay, we have the result or we have the rating distribution, something like this, then you move to the next slide. If you do that, guys, then don't show this slide. You just delete it. When you want to present, just present it. I mean, if you put your slide, this slide, then you need to tell the story. So what is this? You should give us an informations, not just you say that, okay, we have the rating distributions like this, as you can see, and then you go to the next slide. If you do that, then better to delete it. Okay, but I don't know for international student, but for uh Indonesian student, previous semester, above average, I still saw this. Even like when I become committee on other field, not on the computer science one. But on the finance mathematics, or like others laboratory, I still find this kind of things. Okay, this is the result as you can see on the table, and we go next to the slide. It's not good actually. Okay, so you should, if you show this slide, then you need to give us some information, like try to build imagination and try to conclude, actually try to summarize it. And then obtain the ratings of restaurant. To have similar plot at per restaurant level, we need to obtain the ratings of the restaurant. Okay, so then we